Hi guys, this is Mrs. Rooker. Today for day 6 we are doing word problems. So we're applying all of the solving of systems of equations to real world type situations. So in the directions it says to identify the two variables and write the system of equations and then solve the system. So we have to do 3 different things. So I'm going to read each problem and kind of highlight key information in each problem. So the Hamilton family went to the movies and paid $32 for 2 adult tickets and 3 child tickets. The Jeffersons went to the movies and paid $18.50 for just 1 adult ticket and 2 child tickets. How much were the adult tickets and the child tickets? So the first thing we need to identify or do is identify the 2 variables. Variables stand for unknowns, the things that we don't know. If you read the last question, it asks how much are adult tickets and child tickets. Those are going to be your variables. So I'm going to call A adult tickets, or I'm going to call adult tickets A. I'm just going to write ticks. All right, and then I'm going to call C, or I'm going to call child tickets C. So that was me identifying the 2 variables. You are going to be required to do that on each problem, so you need to tell me what the variables are. All right, so that's the first thing. And now we need to write a system of equations. So for our systems of equations, it's going to be 2 different equations. And in this particular problem, we have 2 sentences in the beginning, or 2 sentences. And each sentence represents a different family. So the first sentence said, the Hamilton family went to the movie and paid $32 for 2 adult tickets and 3 child tickets. That sentence is going to be its own equation. So the Hamilton family paid a total of $32. I usually like my totals, that's supposed to be 32. I usually like my totals to be on the right. It doesn't really matter, but that's my total. It's going to be on the right side of the equation. And then that was for 2 adult tickets, so I'm going to write 2A. That means 2 times however much the adult tickets cost, plus 3 child tickets, and that cost a total of $32. So 2 adult tickets plus 3 child tickets equaled a total of $32 is my first equation. I'm going to do that same thing, except I'm going to do this for the Jefferson family. So the Jefferson family had just 1 adult ticket plus 2 child tickets, and their money amount, or their total, was $18.50. So we had 1 equation for the Hamiltons, 1 equation for the Jeffersons. Now we're going to need to use either substitution or elimination to solve for the missing variables. On this particular problem, I'm probably going to use elimination. On a lot of these, I'm going to use elimination. So the first thing I need to do is get opposite coefficients in front of either the A's or the C's. What I think I'm going to do is I'm going to get the A's to be opposite. I'm going to multiply this one by -2. That way, it will cancel out with the positive 2A on the first equation. So when I multiply this, I multiply everything in that equation. So -2 times 1A is -2A. -2 times 2C is -4C. And then -2 times 1850 is -37. So that's what I got when I multiplied that second equation by -2. Then I'm going to stack my equations on top of each other. So I'm going to take this one and just stack it below my equation. and then just combine like terms. The a should cancel. Negative 4c plus 3c is negative 1c equals, and then negative 37 plus 32 is going to be negative 5. Divide everything by negative 1, and c will equal 5. Meaning a child ticket costs $5. Once we know how much the child tickets cost, we can plug back into one of the equations to find how much the adult tickets cost. I'm just going to plug into this equation because it's got 1a, so there's going to be a little less solving that we have to do. So a plus 2 times c, which is we now know is 5, is going to be 1850. A plus 2 times 5 is 10 equals 1850. Then we subtract 10 from both sides. We get A equals 8.5 or 850. All right, that's it for that one. Pause the video if you need to catch up on that. All right, the next one says Jesse is 23 years older than Michelle. If the sum of Jesse and Michelle's ages is 39, how old are they? So we have, again, 2 different sentences, and each sentence is going to be its own equation. But I guess before I get ahead of myself, we need to assign the variables. We are trying to figure out how old they are. There's 2 different people, and we don't know either of their ages. So the 2 variables are going to be Jesse's age and Michelle's age. All right, so back to what I was saying. The first equation is going to be the first sentence. The first sentence is going to be its own equation. So Jesse is 23 years older than Michelle. So some key words here is the word is, and then 23, and then older. So when it says Jesse is 23 years older than Michelle, I write this as Jesse, so J, is the same as is equal to. So Jesse's age is equal to 23 years older than Michelle. So Michelle plus 23, because we need to represent that it's 23 more than Michelle's age. So Jesse is 23 years older than Michelle. Can be represented as J equals M plus 23. So that's the first equation. Now the second equation is going to be this second sentence. The sum of their ages is 39. So you need to know that sum means addition. So we're adding the 2 ages together, and we get 39 as an answer. So J plus M equals 39. And those are your 2 equations. Now you can either use a substitution or elimination. On this one, I'll probably just do substitution because J is already by itself in this first equation. And we can just sub in what J is equal to into the other equation. So since J is equal to M plus 23, I'm just going to replace this J with M plus 23. And then continue writing the rest of this equation. Plus M equals 39. And then simplify. There's nothing to distribute into those parentheses, so they're not really necessary. I'll just combine like terms. M plus M is 2M plus 23 equals 39. And then I'm going to solve by moving things away from the M. So to get rid of the 23, I subtract 23. 2M is all that's left on the left side, equals 16. And then divide by 2. M equals 8. So Michelle must be 8 years old. Michelle is 8 years old. And then Jesse, we can find by plugging back into one of the equations. I'm just going to plug into this first equation. J equals m plus 23. Well, m was 8. So it'll be 8 plus 23, which is 31. So Jesse is 31 years old. And then you can just double check by plugging into the other equation to see if it also works for that equation. J is 31, M is 8, 31 plus 8 is 39. So it works. All right, the next one. At the school play, 825 tickets were sold for a total of $3,150. If adult tickets are $6 and youth tickets are $3, how many adult tickets were sold? So again, we need to assign our variables first. The two things we don't know about are we don't know how many adult tickets were sold. So A is going to represent the number of adult tickets. And then Y is going to represent the number of youth tickets that were sold. All right, the last day of school, 825 tickets were sold for a total of $3,150. Adult tickets were $6 and youth tickets were $3. So on this one, I am going to do two different equations, like always. One of the equations is going to represent the money, and the other equation is going to represent how many tickets were sold. So the first equation is going to represent the money. We know that adult tickets were $6. So I'm going to write 6A to represent that adult tickets are $6. Plus, I know youth tickets are $3, so I'm going to write 3Y for $3 for a youth ticket. And that equals a total of $3,150. So that's my money equation. $6 for an adult ticket, $3 for a youth ticket equals $3,150 total dollars. My next equation is just going to represent the amount of tickets sold. We don't know how many adult tickets are sold, so we're just going to call that A. A just represents the amount of adult tickets. Plus, we don't know how many youth tickets are sold, so we just call that Y. But we know that the total adult and youth tickets sold is $825 tickets. This second equation has nothing to do with the money. It just has to do with the number of tickets sold. All right, now I'm going to use either substitution or elimination to solve this. But you might notice here, the question asks us how many adult tickets were sold. It doesn't even ask us how many youth tickets are sold. So if we want to solve for A first, because then we can avoid even having to solve for the youth tickets. So let's solve for the A first. In order to solve for the A, I want to eliminate the Y. So what I'm going to do is I'm going to multiply this second equation by -3, and that will eliminate the Y's. That'll get it to cancel out with this positive 3Y. So when I multiply, I get -3A minus 3Y equals 825 times -3 is -2475. I'm going to add that with my first equation. So 6A plus 3Y equals 3150. Combine like terms, and I end up getting 6A minus 3A is going to be 3A. The Y's cancel, equals -2475 plus 1350 is 675. And then to get A by itself, I just divide both sides by 3. So I get that A equals 225. So 225 adult tickets were sold. All right, feel free to pause the video if you need to catch up on that. Number 4 says the sum of the digits of a 2-digit number is 12. If the tens digit is twice as big as the units digit, what is the 2-digit number? All right, so we have a 2-digit number. For example, I don't know, it could be like 82. That's a 2-digit number. We don't know what it is, but we know that it's got a tens digit and a units digit. Units digit is also called the ones digit sometimes. So we have a tens digit and a units digit. This is just going to be my blanks that I'll fill in for my 2-digit number. All right, so I'm going to call the tens digit T, and the units digit I'll call U, and that'll be my 2 variables that I'm assigning, because that's the first thing I always need to do. And then my first equation is going to be this first sentence. The sum of the digits of this number is 12. So the sum of the 2 digits is 12. Sum means addition. So I'm going to add the 2 together, and that is going to equal 12. So tens digit plus units digit equals 12. That's my first equation. My second equation is going to be this second sentence. If the tens digit is twice as big as the units digit. So the tens is twice as big as the units digit. Twice is the same as 2 times the units digit. Twice means 2 times. I don't want to write x because that looks like a variable. So 2 times is what twice is. All right, this one's really well set up for substitution because you can see that t is already by itself on this second equation, and this 2u is what t is equal to. So I can just sub that in for my t in the first equation. So I replace the t in the first equation with 2u, and then I continue writing the rest of the first equation. So plus u equals 12. And then I just have to combine like terms. 2u plus 1u is 3u equals 12. And then last step, divide away the 3. U equals 4. So the units digit is 4. So I filled that in my little fill in the blank. Once I have u, I can plug back in to find t. I'm just going to plug into this equation. T equals 2 times u, which is 4. So t equals 2 times 4 is 8. So t is going to be 8. So the tens digit is 8, the units digit is 4. And we can check by plugging into this one also. If t is 8 and u is 4, 8 plus 4 equals 12. So it works. And then look back at what the question is asking. It says, what is the 2-digit number? So the 2-digit number is 84. All right, pause the video if you need to. All right, number 5, and that's my name. Whoa. Mrs. Rooker's coin jar only has nickels and quarters. If there are 400 quarters in the jar, that total $70, how many nickels and quarters are there? Okay, so this one's a little tricky, so make sure you follow along because there will be ones like this on the test, and there will be ones like this on the homework, and you'll want to be able to refer back to your notes so that you can learn these. All right, so we have 400 total coins in the jar, and we have a total of $70. How many nickels and quarters are there? So The first equation, I want it to be kind of my easy equation, and it has nothing to do with the amount of money that everything is worth. It's just going to be the number of coins. And actually, I need to backtrack. I need to assign my variables. So I have two things that I don't know how many there are. I have nickels and quarters. Okay. All right, so I don't know how many nickels there are, and I don't know how many quarters there are, but I know that there are a total of 400 coins. So that's my first equation. It just represents the amount of nickels plus the amount of quarters is going to be 400 total coins. The next equation is going to represent the amount of money that everything is worth. So nickels are 5 cents. And quarters are 25 cents. We want to write those as decimals because they're not worth $5 and $25. And this, our units right now is in dollars. So we need to write them as decimals. 0.05 per nickel plus 0.25 per quarter equals $70 or 70.00. We're not going to write the 0.00, but it's $70. All right, and then on this one, we want to use elimination. That should probably be the easiest for you. I guess you could do substitution, but I prefer elimination. And I'm going to eliminate the q's first. Otherwise, I'd have to multiply by something pretty big to cancel out the ends. So I want to cancel out the q's. I have 0.25, and I need that to somehow cancel with just 1 quarter. If I multiply this bottom equation by 4, there are 4 quarters in a full dollar, and so that will end up giving us a full dollar here, which will cancel out with this, which is a whole number. But I want it to be negative, so it'll cancel out. So whenever I have quarters and I want to cancel those out, I multiply by -4. All right, so I multiply everything by -4. 0.05 times -4 is going to be -0.2 n. And then 0.25q times -4 is going to be -1q. And then 70 times -4 is going to be -280. So that's what I got when I multiplied my second equation by -4. Then I'm going to add that or combine like terms with my first equation. Remember, this is 1n here. So 1n minus 0.2n is going to give us 0.8n. The q's cancel. And then we have 400 minus 280. We get 120. And then to get rid of the 0.8, since that's right in front of the n, we have to divide by 0.8. So we have 0.8n equals 120. We have to divide everything by 0.8. And we get n equals 150. So there are 150 nickels. All right, and then we plug back into whatever equation looks easiest in order to find out how many quarters there are. I think this first equation looks easiest. So I plug in n, which is 150, plus q equals 400. To solve for q, I just subtract the 150, and q equals 250. So this is my answer, that there are 150 nickels and 250 quarters. All right, so I'm going to scroll back through these for you guys. So you can pause and write all this stuff down because there will be problems like this in your homework and you'll want to refer back to these notes to do these. So go ahead and pause and write down these problems if you missed any of them. All right, have a great day, guys.